All right, so now we've learned the general profit formula, but this opens up a whole bunch of other things. That's why CVP is not just break even, it's a technique that's used for many things. I'll just illustrate 4 things that we could use the CVP relationships to cover, and we did break even. But now we'll look at target profit, profit planning, and some scenarios. Okay, then we go back to Excel, and then we can look at each of these in turn. All right, so we did the break-even point, and there is a shortcut to it. But the shortcut for break-even in units is equal to, and it's the fixed cost divided by the profit contribution per unit. So we could have gone through the derivation on the left using the profit equation, or we could do a shortcut. So just to show you it works, equals the fixed cost of 10,000 divided by the unit contribution, 4 minus 1.25, and we get 3636, which is the same as this number, right? So the units on the left side are exactly the same, mathematically the same, but it's not a shortcut. I find that the profit formula is handy as a general purpose, but as you get more familiar with the analysis, you'll quickly find these little shortcuts are pretty handy. All we're doing is we're skipping forward down to this step and then expressing it with variables. That's all we really did. All right, next is we want to earn 50,000 profit in a month. How much will we have to sell given what we're having as unit costs and fixed costs and price? How much do we have to sell to make that profit? Well, let's just copy this over. And let's just fill it out. So profit, we want now to be 50,000. And that should equal the price. We know that's 4 times the quantity. That's the unknown. Minus 1.25 times the quantity minus the fixed cost of 10,000. Notice all I'm doing is plugging in the numbers corresponding to these variables. And now we can solve the equation. 50,000 equals 2.75Q minus 10,000. Then we can combine terms, bring the 10,000 to the left side, so we end up with 60,000 equals 2.75Q. And finally, we can solve for Q, and equals 60,000 divided by 4 minus 1.25, and that equals, just do it over here, 60,000 divided by, friends, 4 minus 1.25, and the answer is 21,818. And let's again say, what is that in days? Divide by 30 days, that's 700, divided by 10 hours a day is 72 cups. That's 1 every minute. Now you might say, well, is there a shortcut for this one too? Yeah, there is. So let's say the shortcut for target profit equals, and the numerator is the target profit plus the fixed costs divided by the profit contribution per unit. And we can just do this on the side, the shortcut. Target profit was 50,000 plus 10,000. Don't forget the parentheses or you'll mess up. And the denominator is 4 minus 1.25. And we should get to the same number right here. So we see that, again, either the long way or the short way works because they're both arithmetically or mathematically identical. All right. So that is, if we wanted to make 50,000, now we know how many cups of coffee we have to sell. All right, next we can do another scenario. In this particular case, it says, well, I know my break even now, and I think I'm going to sell 30,000 cups of coffee in a month, about 1,000 a day. How much money would I make? Same thing. Use our handy profit formula. Again, notice it's the most versatile of the things we've looked at, so we just use it again here. So now let's fill in the variables that we know. We don't know the profit, so that's still unknown. And we know the price is 4. And we know the quantity now is 30,000. Minus $1.25 times 30,000 minus 10,000. And that's the formula. So if we did that calculation, let's just do it here. It is 4 times 30,000 minus 1.25 times 30,000. That quantity minus 10,000. And the answer is we would make $72,500. So we would make that much as our profit. All right, so if somehow we could sell 1,000 cups of coffee a day, we'd be doing pretty well, even doing better than the target profit of 50. So next is profit planning, where we play around with scenarios. So we said, well, let's take our base assumption is selling 30,000 cups, and we say, well, how much would profit change if we start tinkering with things? If we raise price by 10% and we estimate that would reduce our sales by 5%, would that be a better profit or a lesser profit? Right? It makes sense that as you raise price, you sell less coffee, but it also means that if you sell fewer cups of coffee at a higher price, you may make more money. So let's try it out and see if we're better off or worse off. All right, so now we can go ahead and put in the profit formula and fill in the blanks. All right, so profit equals price times Q minus variable cost times Q minus the fixed cost, right? So we got that. So let's do them slowly. So price, what is the price? Price is going to be equal to 4 times 1.1, right? 10%. So it's $4.40. So now we can figure out the quantity. So the quantity would equal 30,000 times 0.95, because we're going to lose 5% of our sales with the price increase. And that is 28,500 cups of coffee. And now we can do the profit. Profit with price increase equals, and we can go equals $4.40 minus 1.25 times 28,500 minus 10,000 equals 79,000. Okay, so we compare the 79,000 to 72, and this is higher. So price increase earns more profit if we only lose 5% of our sales. Notice this is a big if. We don't know. We just kind of hoped, maybe, that we only lose 5% of our sales. Okay? So that is our fourth scenario. So notice what we just did. We took one basic idea, the profit formula, and we did 4 different things. What's the break-even point in units? Oh, by the way, sometimes people say, what is that in dollars? Well, that's really easy. The units are that times $4 means the sales would be this amount, 14,545. All right. So if that's the case, we would break even. The next analysis we did was target profit. How many would we have to sell if we wanted to earn 50,000? Answer, 21,018 cups of coffee. Next is, well, I think I could sell 30,000. What is my profit at 30,000? So we just plugged in the 30,000 as the quantity, kept other variables we had, and figured out the profit of 72,500. Last scenario is, well, let's do something else. Let's say we raise price by 10% from 4 to 440, but we lose some volume from 30,000 cups down 5% because a higher price might lead some people to not buy our coffee or not buy anybody's coffee. And what happens then? And what we found in this particular scenario, that the price increase generated more profit than the loss in profit from a reduced volume. So if we are sure of the 5% decline, then we would make more money by raising price to $4.40 per cup of coffee. All right, so now what we've done is break-even analysis and 3 other variations of CVP. Next, we'll look at when would people use CVP. Let's say we're a for-profit company. It answers basic questions like what sales volume would a McDonald's need to cover its costs? Well, that's break-even point. Or how many cappuccinos must Starbucks sell to earn profit of $50,000? Well, that's target profit. Or what profit would OfficeMax make if they had a sales volume of 200 million? Well, that's profit planning. Or what would happen to Disney's profit if they raised their ticket price by 10% and their fixed cost rose by 8%? Well, that's a scenario that we could also simulate using CVP. Now, CVP is also used for not-for-profit companies, nonprofits, even governmental organizations. Why? We could use it for establishing service levels, like for a certain amount of money, how much output can we have in terms of services? Or look at a fundraising event and say, how many tickets do we have to sell in order to generate profit from running the event? And third is, what are your funding requirements? If you put together all the volumes of services you want to employ, and you look at all your costs putting on your nonprofit, you can figure out the total loss that you would generate, and that loss is how much you have to raise to cover your costs. Some examples for nonprofits would be, how many homeless people can the homeless center house with a budget of $400,000? Well, that's profit planning, right? If we know our variable costs for serving one homeless person, and we know our fixed costs, then we can then determine how many homeless we can serve for $400,000. Next is, how much money must be raised at an alumni event for Princeton to provide 50 full scholarships? Well, we have to price out what's the value of 50 full scholarships, and then work that into our profit equation to say, how many tickets must we sell given the cost per unit and the fixed cost for the event? And we can figure out how many tickets we have to sell to our alumni event. All right, there are certain assumptions behind CVP, because this was way too easy, right, for a master's level business class. Well, it turns out that this is a good shortcut to give us the overall view of the profitability of different products or entities. But we have to know we took some shortcuts and made big assumptions. What are these? All costs are fixed or variable. Notice we didn't have some that moved a little bit with the rise in volume and then moved a little bit more later on. No, it was either fixed or variable. And that the cost function is linear. And that's what we just mentioned, that the cost per unit is the same, whether you're your first cup of coffee or your 1,000th cup of coffee. It was always $1.25. It's not always that simple, right? But we make that assumption, so it makes the math easy. Same thing with fixed costs. Yeah, rent's fixed, but maybe some of the other costs, like salaries, may go up because you may need an extra barista at some point. So those costs may not rise as steadily as the coffee beans, but they do go up if we hit a certain threshold. So we make an assumption again that all costs are either fixed or variable. Next is the revenue is linear. What that means in English is that we have the same price. We don't have a certain cup of coffee in the morning at a different price in the afternoon or late in the evening. It's $4 a cup. Next is that we did one product, but most companies have more than one product. So what do we do then? We can actually make an assumption about sales mix, and that assumption would enable us to do CVP even if we have multiple products. We'll get into that when we get into the actual course of accounting. And then there's only one activity cost driver, unit or dollar sales. So there are no other factors like overtime that would affect our operations or our cost or our efficiency. So these are the simplifying assumptions behind CVP. But the good news is, if we're okay with these assumptions, then we can do a lot of very simple math to give us some pretty interesting insights. The one thing that saves us in these assumptions is what we call relevant range. Relevant range means that in the range of operations from 5,000 cups to 10,000 cups, that the costs don't change too much. And that saves us, because costs may have funny shapes to them, but hopefully in the range we're working with, it approximates a straight line. And if that's the case, then we're in good shape.